Understanding the Basics of Logistic Regression Part 2. By the end of this topic, you will be able to explain the term logistic in logistic regression, describe the loss function used in logistic regression. Let's continue our discussion on the basics of logistic regression. In the end of the previous video, we asked you a question: do these predicted values make any sense? In the housing prices data, the predictions were directly associated with the sale price of any house. But the same cannot be for this example. Having a negative value or a value greater than 1 is meaningless, since either you are a job seeker, that is class 1, or you are not, that is class 0, and your predicted values of y should be bounded by these upper and lower limits. So how can we make the predictions more meaningful? Now, as we are trying to predict a class category, perhaps we can work with probabilities between 0 and 1. But how do we do that? We can perhaps do that by finding a way to transform the line into the resultant red line as shown in the figure. By doing this, the predicted values will remain between 0 and 1. But how do we do that? We know that the equation of any linear regression line is given by z is equal to mx plus c. Now, in order to restrict the values of the prediction between 0 and 1 to make predictions as probabilities, we use a logit function also called sigmoid function. It is a function which has a range between 0 and 1. Irrespective of any input, it will always give output 0 and 1. In our case, the output represents the probability. This function given as g of x equal to 1 upon 1 plus e raised to the power minus x. So if we apply this function to the linear regression line, the prediction can be generated as follows: y equal to g of z. And if we substitute the value of z into the equation and expand it, we get y hat is equal to 1 upon 1 plus e raised to the power minus mx plus c. Alright, so we have some equation which looks very complex, but what does it actually do? If the calculated value of z, that is mx plus c, is very large positive value, the value of e raised to the power minus mx plus c will be e to the power a very large negative number, which is approximately 0, and hence value of y will be restricted to approximately 1. Similarly, if the calculated value of z, that is mx plus c, is very large negative value, the value of e raised to the power minus mx plus c will be e to the power a very large positive number, which will restrict the value of y hat tends to 0. Hence, this sigmoid function restricts the predicted values between the points 0 and 1 and the resulting predictions in the shape of the alphabet S as shown in the plot. Even in the case of outliers, this transformation we performed using the sigmoid holds very well and deviation observed is minimal. Now that we have understood the basics of logistic regression, can you now answer why we call this technique as regression? It is because we are still predicting continuous probability values between 0 and 1, and hence it is a regression. Also, we are using a logit function, therefore it is called a logistic regression. But on the basis of probabilities, we can now set a threshold to decide whether it is class 1 or class 0. For example, if logistic regression gives us a probability of 0.82 that the person with a given number of training hours is a job seeker, we can say that this candidate has a very high probability of being a job seeker and therefore label it as class 1. The important thing to note is that logistic regression in sklearn automatically converts the probabilities into classes by itself using 0.50 as threshold. We can also play around with probabilities and thresholds, which we will see during the implementation phase. So we have now learned how to draw a fancy looking shape on a plot instead of a straight line, but how do we know what to draw exactly? We do not. But we already know what can help us in doing this. Can you tell? Gradient descent. Yes, gradient descent technique is still usable with small changes in it. Let's see what is new this time. Now we know that our logistic regression equation is represented as shown on the screen. As a result, when we use the cost function which we saw in the linear regression problem, and as we already know, we get a non-convex plot as shown on the screen. And as we already know, gradient descent can only work with the convex functions to find the ideal value of parameters. Therefore, we need to find something else to use for cost function. In case of logistic regression, we are dealing with probabilities. Therefore, we use a different loss function called the log loss. It is formulated as shown on the screen, where y hat equal to predicted probability for class 1, y equal to actual class, n equal to number of observations. So for now, we just need to focus on how log loss is calculated. To understand it in detail is currently out of scope of this training. Now you might be asking, we have changed the loss function, this will also change the gradients we obtained using the partial derivative. Your question is completely valid, but the beauty of mathematics is such that when we partially differentiate the log loss function, it turns out to be a similar expression as we formulated while we were looking at the gradients of linear regression, that is predicted minus actuals. Although these expressions are not the direct results of the partial differentiation and require quite a bit of manipulation of mathematical terms, you can find the link covering the demonstration of this manipulation in the helper text below. Once the optimal parameters are found using the process of the gradient descent and the optimal predictions are made as probabilities between values of 0 and 1, but how do we decide which observation should we label as class 1 or as class 0? As the probabilities are between 0 and 1, and we are considering a binary classification, it is intuitive to choose 0.5 as middle point. This middle point is regarded as the threshold. Now, if a probability of any observation is above the value of threshold, it is regarded as class 1, and if the probability is below 0.50 threshold, then we will label it as class 0. Logistic regression in sklearn uses 0.5 as its probability threshold. But we can also choose to use some different probability threshold as per our requirements. So that's it for this video. In the next one, we will understand the confusion metrics and the evaluation metrics for the classification problems. See you then.